In this lecture, we discuss how we can obtain the performance of CPU. So the performance of CPU is inversely proportional to the CPU time. That means if the CPU time increases, that means performance is decreasing. If CPU time is decreasing, that means performance is increasing. So now how to calculate the CPU time? So CPU time is equal to N into CPI by CR. So what is N? CPI and CR. N is number of instruction. CPI is clock cycles per instruction. And CR is clock rate. Okay. So N into CPI, it will give total number of clock cycle. Total number of clock cycles for a program. Okay. So if you want to convert into second, then we just divide by clock rate. Okay. So now just take one example here. A system has 100 megahertz processor. So this is your clock rate. And the program contains 50 instructions. Each instruction takes 10 clock cycles and find out the CPU time. Okay. So here number of instruction is 50. CPI is 10 clock cycle and clock rate is equal to 100 megahertz. Okay. Now just find out the CPU time. So CPU time is equal to N into CPI by clock rate, which is equal to 50 into 10 divided by 100 mega. So it will translate into second. So now just find out time microsecond. So CPU time for this system is 5 microsecond. So if N and CPI and clock rate is given, you just calculate CPU time by using this equation. Now we will discuss how to find out effective CPI. Okay. So in the already we know that calculate the CPU time. So N into CPI by clock rate. So that CPI is the average CPI. Okay, that is an effective CPI. So now we'll discuss how we calculate that effective CPI. Now, so as you know that there is different type of instructions. Okay, you can say different type of instruction classes or types. So accordingly that classes will take the different clock cycle per instruction. So in that case, how to calculate? So overall effective CPI is equal to sum of I is equal to 1 to n Ni into CPI I. So what is this M, Ni and CPI? M is your number of classes or number of types of instruction. And Ni is the number of instruction present in that class I. And CPI I is the clock cycles per instruction for that class I. Okay, so this is your effective CPI I. Effective CPI I, how to calculate. Now, just we'll see through the one example. See here, the first column is the instruction types, or you can say class, frequency, and CPI in clock cycles. So there is 4 type of instructions: ALU instruction, load, store, branch. What is the frequency? The 50% of program is the ALU instruction, 30% of instructions are load instruction, 5% are store, 15% are branch. And ALU instruction take 4 clock cycle. That means 1 ALU instruction take 4 clock cycle. Load instruction take 5 clock cycle. Store instruction take 4 clock cycle. Branch instruction take 2 clock cycle. Now we will see how to calculate effective CPI. So effective CPI is equal to what? Sum of I is equal to 1 to n Ni into CPI I. Okay. So how many classes? 4 classes. So that means sum of I is equal to 1 to 4 what's the frequency? 50%. So 0.5 into CPI 4 plus 30%, 0.3 into 5 plus 0.05 into 4 plus 0.15 into 2. Just add it. So after the addition, you will get 4 clock cycle. Okay, 4 clock cycle. That means your effective CPI is 4 clock cycle. So already we find out how to calculate the CPU time. Okay, if CPI is not given directly for a program, okay, so if it is classified into set of instructions like set of types, and for each type CPI is given, then just put this formula to calculate the CPI. Okay, now after that use that CPU time formula, n into CPI by clock rate. So you just put this CPI value on that. Now you can calculate the CPU time.